Hello, and welcome to a brief introduction to how AtScale partners with Snowflake to optimize your enterprise reporting and analytics, with a special focus today on the Microsoft stack. Now, you're probably familiar with both Microsoft and Snowflake. Just to point out a couple quick things about AtScale, the AtScale platform provides a couple key benefits. The first of these is what we refer to as a universal semantic layer, which allows you to eliminate the silos built around multiple different BI tools and coordinate them all together to a single point of design and maintenance, supporting both SQL-based tools and other tools that may run on MDX and or even have a DAX interface, as we'll see in a moment. Secondly, AtScale also performs something we call autonomous data engineering, dynamically optimizing the physical data structures in Snowflake to best match what your users are doing with that data. Now, just briefly, we'll pass through the architecture quickly. One thing I want to point out is that all of the data remains resident in Snowflake. AtScale does not egress the data out of Snowflake to some sort of bespoke data structure elsewhere. All that data stays where you put it in Snowflake for all the benefits that you get from that Snowflake platform. Once again, connected to multiple BI tools, whether they happen to run on SQL or MDX, or even with that DAX interface, as we'll see in a moment. So just quickly here, what we're going to look at is that Microsoft stack, starting with Active Directory, which of course could be on-prem or might be Azure AD. We'll take a look most directly at Power BI today, accessing AtScale with automatic authentication from the Windows environment, talking to AtScale through that DAX and MDX-based interface. We'll see how that universal semantic layer looks and works. We'll see how end user security is applied, either at a per user or AD group level. And then we'll also get a look at how that autonomous data engineering helps us scale to truly limitless volumes of data on the Snowflake platform while giving your users the kind of conversational response time they need to be efficient in their analysis and making intelligent usage of the different warehouses available in Snowflake to optimize each query process on the Snowflake platform. All right, let's take a quick peek at how these things look and work. Now, at the moment, I'm logged into a Windows 10 workstation as a member of our TOLA region in the United States. This user has access to just a few states of data in the United States. Now, let's take a quick look first at what's actually going to be interacted with. So this is a model in AtScale that I've built, and this is built on a TPC-DS data set. If you're not familiar with that, that's an industry standard benchmarking set for data warehouses and BI tools. Now, I happen to have this built up around a couple core fact tables. So I have my physical store sales, I have web sales in a different fact dimension here, a number of common dimensions that are shared between those, maybe some other dimensions that apply only to one side of the business or the other. Now, through the modeling that I've done here, I have access to see what this is going to look like to my end users as they interact with this universal semantic layer through their BI tools. So I can see many different categorizations of the different measures for my different fact tables. I can see, for example, my demographics information, my product dimension and its attributes, so on and so forth, that I've modeled here in AtScale for my end users. Now, before we take a look at this in a BI tool, I also want to switch to Snowflake quickly, just to point out that this is actually a really large data set. So I'm not going to go through obviously all the tables involved here, but if we look at those two core fact tables that I was just pointing out, that store sales table is 288 billion rows of data, nearly 11 terabytes. The web sales adds in another 72 billion rows, almost 5 terabytes. So this is a very large data set that we're actually going to be working with today. So you can see how AtScale optimizes that scale and performance. Now, just quickly into a report that I have here in Power BI. If we look over on the right side, we'll take a peek at how that universal semantic layer appears to the user in the BI tool. So as you can see, here's all those store sales measures we were looking at. Let's take a look at our product dimension. Here's all of my different product attributes and the actual hierarchy here, so on and so forth, with all the different items that we have modeled for our users to interact with, automatically appearing in Power BI by virtue of the fact that Power BI is now connected to AtScale. Now here on my simple little display, again, this is a TOLA region user. So if they drill down into the United States, for example, of course, they'll only see the states that they have access to, maybe continue on down to see just one individual state. If I wanted to see, breakouts for all the parishes in Louisiana, for example, I can drill down there. And notice again that this is actually just a row counter of my transactions. So 46 billion transactions actually just here in Louisiana. And likewise, of course, I can drill up and down on my product dimension here, going from product category to product class, maybe on down to individual brands, etc. So as you can see, interacting with this data, extremely fast response time, getting a sub-second to few second response, really for anything that I do as an end user, regardless of the fact that there's literally hundreds of billions of rows of transactions behind this dashboard. Now, just briefly, I'm going to go ahead and switch users just so we can see this at work. I'm going to go and log in as a Midwest user. So obviously someone who's going to have a different security profile than the TOLA user that I was just logged in as. So now that I'm logged in as this Midwest user, if I drill down here, of course, I'm going to see a different set of states. Could continue to go on once again into individual states and do the same things that we were doing before. All that drill down, that sort of slice and dice, different analytical things that you can do in Power BI, all happening once again sub-second to just a few seconds, regardless of what I happen to be up to there in my dashboard. Now, if we go back and take a peek at what's kind of happening here in the background, in AtScale, if we go and look at the actual queries coming in, we'll see a couple interesting things. So if I look at, for example, this TOLA user query that came from Power BI, we can see that this comes in as a DAX request. So Power BI accesses AtScale through a DAX and MDX interface, just as it does for SQL Server Analysis Services. Now, naturally, Snowflake doesn't have a DAX or MDX interface, but AtScale is able to accept that kind of request from Power BI and then translate it through to Snowflake optimized SQL so that that executes on the Snowflake platform without having to move that data somewhere else. And here you can see that little bit of security being applied to those users automatically as they interact with that data based on their Windows authentication coming from that single sign-on integration with Active Directory. Now you'll notice I've got a table here that is this blue hyperlinked item, and then there's always a list towards the bottom. These are these net new data structures that AtScale created as part of that autonomous data engineering we briefly talked about that we call acceleration structures, or for short, just aggregates. Now we can actually go and take a peek at what's going on with that aggregate engine. I'll go ahead and just look at all of my active aggregates for that particular model we were looking at. Now, some of these are going to be really, really small. Some of them will be really big, depending obviously on your different query patterns and the data you're working with. Let's go ahead and take a peek at what one of these looks like. Now, this particular one, as you can see, has 1.7 million rows of data in it. That might seem like kind of a lot of data, but it certainly isn't to Snowflake. That's actually a pretty small table at this point from Snowflake's point of view. If we look at what's in here, this is basically the intersection of my customer geography dimension and my product dimension. And you can see all the different measures here that we know have relationships to those dimensions. Now, that 1.7 million rows here, of course, was boiled down from those hundreds of billions of transactions to start with. And that job on Snowflake actually took about an hour. And that hour of processing was actually on a 2XL warehouse. So a pretty beefy warehouse took an hour to create this aggregate. That's a lot of work to get done. And you certainly wouldn't want your end users to be waiting for those kinds of query times. Now, because we have that aggregate created, we can see how many times that's been utilized. And based on the fact that we have created that aggregate, we've already saved many, many hours of actual query time for our end users by virtue of the fact that AtScale is able to leverage this aggregate at runtime to service those end user requests instead of having to go back to the hundreds of billions of rows to process that data from the ground up. As AtScale goes through that autonomous data engineering process, it's basically a practice of minimizing the volume of data that any given query pattern has to run against. And at the same time, simplifying the logic involved. So taking care of things like joins between tables and calculation definitions and security or governance constraints, all taken care of up front in that job so that at runtime, when the users come through and they leverage this aggregate, AtScale automatically accessing and using that on the fly, we are able to actually run that at runtime through an extra small warehouse on Snowflake as I go into my connection information for my Snowflake environment. Because of the way that Snowflake totally segregates storage and compute, we are able to leverage different warehouses for different job profiles. So for example, I have that 2XL I've been talking about that does my ag build jobs. That's really the heavy lifting, and those happen only periodically, maybe once a day. But at runtime, I have my end user queries coming through an extra small warehouse. So if we go back into Snowflake and take a peek at query activity coming through, we can see that all of these jobs are coming through at runtime on this extra small warehouse, doing all of that work for the end user off of those aggregates, getting response times measured in milliseconds, scanning very small sets of data because of the result of that autonomous data engineering that AtScale does for you. So this is it for today. Just a very brief introduction to how AtScale and Snowflake combine to optimize that reporting and analytics environment. Looking today specifically at Power BI. We hope you've enjoyed this, and certainly if you have any questions, feel free to reach out and we'll be happy to hear from you. Thanks a lot.